Euclid Maths, Euclid Maths, Euclid Maths.
Hi everyone, welcome to our lecture series on vector differentiation. This is part 6, in this lecture series. We are going to learn tangent planes now. Enjoy the lecture.
What is a tangent plane? Consider a scalar field f from R3 to R. It can also be written as W equals f of x comma y comma z. Suppose a point P x0 comma y0 comma z0 is given on this surface. Tangent plane literally touches the given surface at this point P x0 comma y0 comma z0. Let's see what is the equation of this tangent plane. To find out the tangent plane of the given surface at the point P x0 comma y0 comma z0, we need to find out the dot product between del f and x minus x0 I cap plus y minus y0 j cap plus z minus z0 k cap. The dot product between these two vectors gives us the equation of the tangent plane x minus x0 times dou f by dou x plus y minus y0 times dou f by dou y plus z minus z0 times dou f by dou z. This equation represents the tangent plane of the given scalar field at the given point P x0 comma y0 comma z0. We have seen the directional derivatives and tangent planes so far. Now we solve a few problems. In problem 1, they gave us a surface phi of x comma y comma z equals 4x z cube minus 3x square y square z. They gave us a point P 2 comma minus 1 comma 2 and a vector say u cap is equal to 2i cap minus 3j cap plus 6k cap. Now to find out the directional derivative of the given surface phi of x comma y comma z at the given point P 2 comma minus 1 comma 2 in the direction of the given vector 2i cap minus 3j cap plus 6k cap, we consider the given surface phi of x comma y comma z equals 4x z cube minus 3x square y square z. For this surface, we have to first find out its partial derivatives dou phi by dou x, dou phi by dou y and dou phi by dou z. In this case, dou phi by dou x equals 4z cube minus 6x y square z. Dou phi by dou y equals minus 6x square yz. Now the partial derivative of phi with respect to z is given by dou phi by dou z equals 12xz square minus 3x square y square. Now dou phi by dou x at the given point P we have to find. To find dou phi by dou x at P, we have to substitute x equals 2, y equals minus 1 and z equals 2 in the place of dou phi by dou x. Then we get dou phi by dou x at the given point P equals 8. Now we have to find out dou phi by dou y value at the given point P 2 comma minus 1 comma 2. If we substitute x equals 2, y equals minus 1 and z equals 2 in the place of x, y, z, we get dou phi by dou y at P equals 48. Similarly, Dou phi by dou z at P equals 84. Now we have to find out the gradient of phi. The gradient of phi is denoted by del phi, which equals I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. Here we find out del phi at the given point P equals 2 comma minus 1 comma 2. We obtain del phi at P equals 8 I cap plus 48 J cap plus 84 K cap. Consider the given vector U cap equals 2 I cap minus 3 J cap plus 6 K cap. Now we have to find out its length or norm. Norm U cap becomes root over 2 square plus 3 square plus 6 square, which equals square root upon 49, and it gives us norm U cap equals 7. We have to find out the unit vector n cap. N cap equals U cap whole divided by norm U cap. So n cap equals 2i cap minus 3j cap plus 6k cap whole divided by 7. This gives us a unit vector n cap in the direction of u cap. The magnitude of n cap is 1. The direction of n cap is same that of u cap. To find out the directional derivative of phi in the direction of u cap at the given point P 2 comma minus 1 comma 2, we need to find out the dot product between the vectors del phi at P and the unit vector n cap. So the dot product between del phi at P and n cap is given by del phi at P dot n cap equals 8 I cap plus 48 j cap plus 84 k cap dotted with 2 I cap minus 3 j cap plus 6 k cap whole divided by 7. This in turn gives us del phi at P dot n cap equals 376 upon 7. Problem number 2. In this problem, a surface phi of x comma y comma z equals x square yz plus 4x z square is given to us. We have to find its directional derivative at the point P equals 1 comma minus 2 comma minus 1 in the direction of a vector u cap. In this problem, we need to find this vector u cap. Here, u cap is a normal to the surface g of x comma y comma z equals x log z minus y square. So, we have to divide this problem into two types. First part is we have to find the gradient of the given scalar field phi of x comma y comma z at the given point 1 comma minus 2 comma minus 1. Next, we have to find u cap. U cap can be found by finding the normal to the surface g of x comma y comma z equals x log z minus y square at a prescribed point. Now, let us finish off the first part of this problem. That means in this first part, we find the gradient of the given scalar field phi of x comma y comma z. So in part 1, let us consider the given surface phi of x comma y comma z equals x square yz plus 4x z square. The given point P is 1 comma minus 2 comma minus 1. To find the gradient of the given surface phi, first we have to find out its partial derivatives dou phi by dou x, dou phi by dou y, and dou phi by dou z. First, let us find out these partial derivatives. For the given surface, phi of x comma y comma z equals x square yz plus 4x z square, dou phi by dou x equals 2x yz plus 4z square. Dou phi by dou y equals x square z. Dou phi by dou z equals x square y plus 8xz. Now we find out dou phi by dou x at P, dou phi by dou y at P, and dou phi by dou z at P. Here P is the point 1 comma minus 2 comma minus 1. If we find out these values, we obtain dou phi by dou x at P equals 8, dou phi by dou y at P equals minus 1, and dou phi by dou z at P equals minus 10. By using these values, we find the gradient of phi at the given point P. Del phi at P equals I cap dou phi by dou x at P plus j cap dou phi by dou y at P plus k cap dou phi by dou z at P. If we plug in the values of the partial derivatives at P, we get del phi at P equals 8 I cap minus j cap minus 10 k cap. In the first part, we have found the gradient of the given scalar field phi at the given point P 1 comma minus 2 comma minus 1. So, we want the unit vector to find the directional derivative of the given surface. For that, we need to find out a normal to another surface g of x comma y comma z at the another point, say Q. Consider that second surface g of x comma y comma z equals x log z minus y square. Let that second point be Q equals minus 1 comma 2 comma 1. Now, to find out a normal to this new surface G, we have to find out the gradient of this surface G also. For that purpose, we have to find out the partial derivatives of G. So we need to find out dou G by dou x, dou G by dou y, and dou G by dou z. For this given surface G of x comma y comma z equals x log z minus y square, dou G by dou x becomes log z, dou G by dou y equals minus 2y, dou G by dou z becomes x by z. Now, we have to take Q equals minus 1 comma 2 comma 1. So here x value is minus 1, y value is 2, and z value is 1. We have to plug in these values in del G. Here we need to find out del G. Del G equals I cap dou G by dou x plus j cap dou G by dou y plus k cap dou G by dou z. Del G equals I cap log z minus 2y j cap plus x by z k cap. If we want del G at the given point Q, we have to substitute x equals minus 1, y equals 2, and z equals 1. If we do so, the gradient of z at the point Q, del G sub q equals minus 4j cap minus k cap. We can suppose this vector as u cap. So we can take u cap equals del g at q, that equals minus 4j cap minus k cap. According to our procedure, to find the directional derivative of phi in the direction of this vector u cap, that is del d at q, we have to find out a unit vector n cap. How to find this unit vector n cap? N cap equals u cap by norm u cap. In this case, n cap equals del g at q divided with norm del g at q, which is equal to minus 4j cap minus k cap whole divided by root 17. This gives us the n cap. Now, we have to find out the directional derivative of the given surface phi at the given point P in the direction of u cap. Here u cap equals del g at q. Now we have already found a unit vector n cap in our previous part. Now it remains to find out the directional derivative of the given surface in the direction of n cap, which is also the direction of u cap. For this purpose, we have to find out del phi at p dot n cap. This gives us the required directional derivative. So, del phi at p dot n cap equals 8i cap minus j cap minus 10k cap dot minus 4j cap minus k cap by root 17. The dot product is 14 by root 17, which is the required directional derivative of the given surface in the direction of the normal to the second surface g of x comma y comma z equals x log z minus y square at the point q. We are done. Problem number 3. In this problem, we have to find out a tangent plane to the given surface at the given point. In this problem, the given surface is xz square plus x square y equals z minus 1. The given point P is 1 comma minus 3 comma 1. To find out the tangent plane to the given surface at the given point 1 comma minus 3 comma 1, first let us consider f of x comma y comma z equals xz square plus x square y minus z plus 1. This is our given surface. Let the given point P be 1 comma minus 3 comma 1. Suppose that x naught equals 1, y naught equals minus 3 and z naught equals 1. To find out the tangent plane, first we have to find out the partial derivatives dou f by dou x, dou f by dou y and dou f by dou z. In this case, dou f by dou x becomes z square plus 2xy. Dou f by dou y equals x square. Dou f by dou z equals 2xz minus 1. Now we have to find out dou f by dou x at the given point P, dou f by dou y at the given point P and dou f by dou z at the given point P. Dou f by dou x at P equals minus 5, dou f by dou y at P equals plus 1 and dou f by dou z at P equals 1. Here in this case We get these values by substituting x equals 1, y equals -3 and z equals 1 in the partial derivatives of f. Now we have our formula of the tangent plane. The tangent plane formula is x minus x naught into dou f by dou x plus y minus y naught into dou f by dou y plus z minus z naught into dou f by dou z. If we plug in all our values in this tangent plane formula, we get the tangent plane to the given surface at the given point is minus 5 times x minus 1 plus y plus 3 plus z minus 1. If we simplify this value, we get minus 5x plus y plus z plus 7. We can also equate this to 0. That means our tangent plane equation may be minus 5x plus y plus z plus 7 equals 0. Thus we can find out a tangent plane to the given surface at the given point. We are done.
I hope you are enjoying our lectures. If you prefer any specific topic, please let me know in the comment box. You can write a mail to us for our lecture notes. Please subscribe our channel and press the bell for notifications. If you like the content, spread the word. Thanks for watching.